Today we're looking at vector valued functions and calculus. So a couple things we need to do are we need to define what a position vector is. So for a position vector, I usually use S because we already are using X in as one of the components of the vector. So S is something different than X, okay? We write the position vector as the X coordinate, the X position, comma, Y position. So it gives us any, the position vector gives us any location of the point. The velocity vector would just be X prime of t, comma, Y prime of t. And acceleration vector would be the acceleration of X is X double prime, and the acceleration of Y would be Y double prime, okay? With respect to t. Speed of a vector is just the magnitude of the velocity vector. So what I do is take remember magnitude is just like the length of the vector. So we take our velocity vector, which is made up of X prime and Y prime, and then we square those values, add them together and take the square root to give us the magnitude. Okay, total distance traveled, or distance traveled, is the integral of velocity. So we put the distance is equal to from when to when we're traveling, that's our A to B, times of the integral of the square root of X prime of t squared plus Y prime of t squared dt. And then the particle or the vector is at rest when the velocity is equal to 0, but we have to make 0, the velocity has to be 0 in both the x direction and the y direction. Otherwise, you're moving only if like the y was 1, then you'd be moving up still. So when you're at rest, you're neither moving left or right or up and down. Okay. A particle moves in the xy plane so that at any time the position of the particle is given by x of t equals t cubed plus 4t squared, and y of t is equal to t to the fourth minus t cubed. Let's find the velocity vector. So I know that position vector is just made up of x of t comma y of t. So to find the velocity vector at time 1, what I want to find is x prime of 1 comma y prime of 1. And I'm just going to do the work on the side. That is not pretty. Okay, so we have x prime of t is equal to, okay, the derivative of t cubed is 3t squared plus derivative of 4t squared is 8t. And then we need to find the derivative at time 1. So substituting in 1 for t, I get 3 plus 8 is 11. Okay, let's go ahead and tackle y prime of t. So t to the fourth minus t cubed, the derivative of that would be 4t cubed minus 3t squared, and y prime of 1 is 4 times 1 is 4, minus 3 times 1 is going to give us 1. Okay, so my position vector at, my velocity vector at time 1 would be my x component at time 1 is 11, and my y component at time 1 is 1. Okay, find the acceleration vector at time 2. So we already know what, well, what we need to do is take the second derivative of position and evaluate it at time 2, and then take the second derivative of y and evaluate it at 2. So I already have x prime of t from above. So let's go ahead and take x double prime of t, giving us 6t plus 8. And then we need to evaluate at time 2. So 6 times 2 plus 8. So 12 plus 8 is 20. Okay. And then y double prime of t from above, I'm going to go ahead and say 4t cubed minus 3t squared. The derivative of that would be 12t squared minus 6t. So y double prime of 2 is 12 times 4 minus 6 times 2, which gives me 36. So I get 20 comma 36 as the acceleration vector at time 2. Okay, next example. A particle moves in the xy plane so that any time t, where t is greater than 0, the position of the particle is given by x of t equals t squared plus 3t, and y of t is equal to t cubed minus 3t squared. We're going to find the magnitude of the velocity vector when t is equal to 0. Okay, check it. The magnitude of velocity vector, it means speed. And we find speed by taking the square root of this first derivative, so x prime of t squared plus y prime of t squared, okay? And since we're evaluating this at time is equal to 1, we're going to substitute 1 in for t here. All right, so let's just get all of our values. I need to take the first derivative of x, which is 2t plus 3. And then I need to evaluate that derivative at time 1. So 2 times 1 is 2, plus 3 gives me 5. Now let's tackle y prime of t, which the derivative of y of t is 3t squared minus 6t. And then we need to evaluate that at time 1. So 3 times 1 minus 6 times 1 gives us negative 3. So all I need to do is sub this into my speed equation. So I get the speed, or you can say the magnitude of your vector, we'll call it vector v, is equal to the square root of x prime of 1 squared. So x prime of 1 was 5. So 5 squared plus y prime of 1, which is negative 3, square that. And we just simplify. So I get 25 plus 9, so root 34. So the speed is equal to the square root of 34. Next up, a particle moves in the xy plane so that x equals the square root of 3 minus 4 cosine t, and y is equal to 1 minus sine t, where 0 is less than or equal to t, which is less than or equal to 2 pi. The path of the particle intersects the x-axis twice. Write an expression that represents the distance traveled by the particle between the two x-intercepts. And then we're not going to evaluate this since this is a no calculator question, okay? So what we need to know is where the particle intersects the x-axis. We know that an x-intercept has a y value of 0. Check it. An x-intercept is when y is equal to 0, like some number, comma 0. Okay, so I need to take my x equation, which was x is equal to the square root of 3 minus 4 cosine of t, and set 0. Oh, excuse me, I did the wrong one. We need y is equal to 0. So I need my y equation, which is y is equal to 1 minus 2 sine t. 1 minus 2 sine of t. Substitute in 0 for y. So 1 minus 2 sine t. Okay, subtract 1. I get negative 1 is equal to negative 2 sine t. Divide by negative 2. So I get 1/2 is equal to the sine of t. And I know that on the unit circle, sine of t is positive in quadrants 1 and 2. So my angle t here would be t is equal to pi over 6, and then pi minus pi over 6, which is 5 pi over 6. T and t. Okay, so we're going to find the distance is equal to, we need to find the distance between the two x-intercepts, so between pi over 6 to 5 pi over 6 of the first derivative squared plus the second derivative, or sorry, the first derivative of y squared, and then we add those up and take the square root. So we get the derivative is equal to, sorry, the distance is equal to pi over 6 to 5 pi the integral from pi over 6 to 5 pi over 6 of the square root of, okay, and then above here, I'm going to get my x prime of t is equal to, let's see, square root of 3 is just going to be 0, and then minus 4 cosine t, which gives me 4 sine t as the derivative. And y prime of t is equal to 1 minus 2 sine t's derivative would be negative 2 cosine of t. So I can go ahead and just substitute those in. I get the square root of 4 sine t all squared plus negative 2 cosine of t all squared dt. Okay, and that's the setup for our distance. Couple more. A particle moves in the xy plane so that at any time the position of the particle is given by x of t is equal to 2t cubed minus 15t plus 36t plus 5. And y of t is equal to t cubed minus 3t squared plus 1, where t is greater than 0. For what values of t is the particle at rest? Okay, at rest means that the velocity has to equal 0. So we need the velocity vector to be 0 and 0 for the x and the y components, which means that the x prime of t has to be 0 and the y prime of t has to be equal to 0. So we're going to go ahead and find the derivative of x, which is 6t squared minus 30t plus 36. And then I'm going to set that equal to 0 to figure out when the x component is equal, it has a velocity of 0. I'm factor out of 6, giving me t squared minus 5 plus 6. Divide both sides by 6, so I get 0 is equal to, and I'm going to factor, so t minus 2 times t minus 3. So when t is equal to 2 and t is equal to 3, we have a velocity of 0 for the x. Now the y, let's go ahead and take the y prime, giving us 3t minus 6t, and then we'll set that component equal to 0. I'm going to factor out a 3t squared, sorry, minus 6t. So I'm going to factor out a 3t, giving me t minus 2. So when t is equal to 0 and t is equal to 2, the y component is 0. So now we need the time when both the x and the y components are 0. So that's only when time is equal to 2. So the particle is at rest when t is equal to 2. Okay, last one. The particle moves in the xy plane in such a way that the velocity vector is 3t squared minus 4t, comma 8t cubed plus 5. If the position vector is t is equal to 0, is at t is equal to 0 is 7 comma negative 4. Find the position of the particle at time 1. Okay, that means that this is, the 7 represents x of 0 and negative 4 represents y of 0. So that is the position at time 0. And we need to find the position at time 1, which is x of 1 comma y of 1. Okay, so we're given the velocity vector, so I know that if I take the integral of velocity from 0 to 1, so if I take x prime of t dt from the integral from 0 to 1, using the fundamental theorem of calculus, this equals the change in position. So x of 1 minus x of 0. And I'm going to rearrange this because I want to find x of 1, so I'm just going to add x of 0 to both sides. So I get x of 0 is equal, or plus, the integral from 0 to 1 of x prime of t dt will give me my starting position, x of 1. Okay, So I now have to substitute in the values I know. X of 0 is 7, according to my point, plus the integral from 0 to 1 of 3t squared minus 4t dt will give me my position at time 1. Okay. So I get 7 plus, I'm going to take the integral, so 3 over t cubed over 3 minus 4t squared over 2, evaluated from 0 to 1, equals x of 1. Okay, I'm going to put my x of 1 over here. So I have 7 plus, I'm going to simplify, so I get t cubed minus 2t squared, evaluated from 0 to 1. And so x of 1 is equal to 7 plus, substitute in the 1, so 1 minus 2, and then when I substitute in the 0, I just subtract 0. So x of 1 is equal to 7 plus 1 minus 2, which is 6. Okay, next up, I'm going to get my position of the y component. I am going to do this one different. You do not have to use the fundamental theorem of calculus. What you can do is take the integral of y prime. So I'm going to take the integral, an indefinite integral of y prime of t dt, which is the integral of 8t cubed plus 5 dt. Okay. So I get 8 t to the 4th over 4 plus 5t plus c, okay? And this is going to give me y of t. So to solve for the c value, I need to plug in my y and my initial condition, which is y of 0, is equal to -4. So I'm going to write, okay, 8 divided by 4 is 2 times 0 to the 4th plus 5 times 0 plus c. So -4 is equal to c. Okay. Now that I have my initial condition, I know that y of t is equal to 2, so t to the 4th plus 5t minus 4. So if I want to find y of 1, just plug in 1. So 2 times 1 to the 4th plus 5 times 1 minus 4. So 2 plus 5 is 7 minus 4 gives me 3. So that means that the vector x of 1 comma y of 1 is equal to 6 and 3. I get 6 comma 3. So when you do this, when we take the integral here, you can either use the fundamental theorem of calculus to solve for this other position because we're given an initial condition and the velocity, or you can just use an indefinite integral, solve for c, and then plug in the time that you want to evaluate at. Okay, both work. I just want to show you both. All right. I hope you guys have a good one. Bye.